For centuries, the silent stones of Easter Island guarded their secrets. The massive Moai statues stood as a monumental puzzle, their creation and transport seemingly impossible for an ancient society. How were these giants moved across the island without modern technology? This is just one of many ancient enigmas that have surrendered to the power of modern science. We are about to embark on a journey through 25 incredible cases where cutting-edge technology has rewritten history books and solved puzzles that once baffled experts. By the end, you will understand how science has become the ultimate key to unlocking our past. We will see how a mysterious bronze device from a shipwreck turned out to be an ancient computer, and how the fate of a lost colony was found not in documents but in tree rings. What forgotten story from the ancient world do you find most compelling? The sheer scale of the Great Pyramid of Giza defies belief, a mountain of stone erected with breathtaking precision. For generations, its construction was the ultimate historical riddle, inspiring theories that stretched from alien assistance to lost super-civilizations. Yet science has patiently chipped away at the mystery, revealing a truth grounded in remarkable human ingenuity. The answer did not come from a single discovery, but from a convergence of evidence gathered from ancient quarries, the very soil of Egypt, and painstaking reconstruction. Researchers examining the quarries found remnants of a dedicated harbor, a crucial piece of the puzzle. They realized that during the annual Nile flood, giant barges could transport the massive stone blocks right to the base of the Giza Plateau. From there, how did workers move these multi-ton stones across the sand? The secret was surprisingly simple and elegant. Archaeologists found depictions and evidence of workers pouring water onto the sand in front of heavy sleds. This clever technique dramatically reduced friction, allowing a team to pull a colossal block with relative ease. It turns a seemingly impossible task into a manageable one, a brilliant application of basic physics. But getting the stones to the base was only half the battle. The question of how they were lifted to such incredible heights has been answered by the study of the pyramids themselves. Scans and careful analysis of the internal structure suggest the use of a spiraling internal ramp. Unlike a straight, external ramp that would have been impossibly large, this internal corkscrew allowed workers to haul stones upward from within the growing structure, turning the pyramid into its own construction scaffold. These laborers were not slaves, but a highly organized, skilled workforce. They used tools of copper, the hardest metal available to them, to precisely shape the limestone and granite. Their settlements, unearthed by archaeologists, show they were well-fed and housed, part of a national project that unified ancient Egypt. Science has replaced fantastical myths with an even more compelling narrative, one of extraordinary logistics, simple yet effective engineering, and the coordinated power of thousands. Across the sea, another circle of ancient stones has long captured our collective imagination. Stonehenge stands alone on the Salisbury Plain, its purpose seemingly lost to the winds of time. Was it a temple for druids, a place of healing, or perhaps a monument to powerful kings? For centuries, the theories were as numerous as the stones themselves. But science has slowly peeled back the layers of this mystery, revealing a site of profound complexity. The first major clue came from painstaking archaeological excavation around the monument. Beneath the iconic sarsen stones, researchers uncovered a startling number of human remains, many of them cremated. Radiocarbon dating these bones revealed a timeline stretching back over 5,000 years, showing that Stonehenge was used as a cemetery for centuries. It was, first and foremost, a final resting place for a lineage of elite individuals. Yet the story does not end with death. How did this place function for the living? The answer lies in the sky, the field of archaeoastronomy, which studies how ancient peoples understood the cosmos, provided the next breakthrough. The entire structure is precisely aligned. On the summer solstice, the longest day of the year, the sun rises directly over the heel stone and its rays shine into the very heart of the stone circle. During the winter solstice, the sun sets perfectly framed within the great trilithons. This was not a coincidence. It was a sophisticated celestial calendar marking the turning of the seasons with breathtaking accuracy. But where did the people who built this calendar live? The recent discovery of the Durrington Walls settlement, just 2 miles from Stonehenge, completed the picture. This was a vast seasonal village, occupied only during the midwinter and midsummer periods. Analysis of animal bones found there revealed evidence of massive feasts, where thousands of people gathered from across Britain to celebrate the solstices. They would feast at Durrington Walls and then travel to the stone circle to conduct rituals, honor their dead, and witness the cosmic alignment. Stonehenge was not one thing but many. It was a domain of the ancestors, a monumental clock, and a destination for pilgrimage, all connected by a deep understanding of the cycles of life, death, and the heavens above. Even as the stones of Stonehenge marked the seasons, a very different kind of mystery was unfolding across the Atlantic. In 1587, a group of over 100 English colonists landed on Roanoke Island, full of hope for a new life. 3 years later, a supply ship arrived to find the settlement utterly deserted. The only clue was a single word carved into a post, Croatoan, and the name of a nearby island carved into a tree. The lost colony had vanished without a trace, becoming one of America's most enduring legends. For centuries, the fate of these men, women, and children was a complete enigma. What force could have wiped out an entire community? The first major breakthrough came not from a spade, but from the rings of ancient trees. Scientists using dendrochronology, the study of tree ring patterns, made a startling discovery. The rings from that period showed that the colonists arrived at the onset of the most severe drought in 800 years. This was not just a dry spell, it was a catastrophic megadrought that would have persisted for years. Their wells would have turned to dust, their crops would have failed completely, and their very survival would have been threatened from the moment they stepped ashore. This environmental disaster forced a radical reinterpretation of the clues. The word Croatoan was not a cry for help or a message of distress, it was likely a destination. Facing starvation, the logical choice would have been to seek help from the one group identified by that name, the Croatoan people who lived on a nearby island and had previously been friendly. But if they moved, why did they leave no trace? Modern technology began to find answers where traditional archaeology had failed. A team using ground-penetrating radar detected a mysterious soil disturbance several miles inland from the original settlement. This hidden feature, which they called Patch X, suggested a small, secondary site, perhaps a group that split off from the main colony. Then, a stunning discovery was made on a 16th-century map of the region. Underneath a patch placed on the original map, conservators found a symbol, a 4-pointed star drawn in invisible ink. This star marked a location 50 miles inland, a place where the colonists might have planned to relocate. This was no longer just a story of a single settlement on an island. It was a story of a planned dispersal. The archaeological evidence began to support this. Far from the coast, researchers found European artifacts, including a sword hilt and a signet ring, mixed with Croatoan pottery at a site that was occupied at the right time. These were not items lost in trade, but personal possessions, the kinds of things people would carry with them if they were integrating into a new community. The most compelling picture that emerges is not one of massacre or disease, but of assimilation. Facing an impossible situation, the colonists likely did not vanish. They may have split into smaller groups, some staying on the coast, others moving inland as the hidden map suggested, and all eventually joining with the local tribes for survival. The lost colony was never truly lost, they were simply absorbed, their story becoming a part of a different American history, written not in stone but in the land itself. While colonists struggled for survival in the New World, a shipwreck from the classical era was quietly preserving a secret far more advanced than anyone could have guessed. Spongedivers off the coast of the Greek island of Antikythera in 1901 stumbled upon the sunken wreck of a Roman cargo ship. Among the shattered statues and ancient treasures, they recovered a lump of heavily corroded bronze, its original form completely unrecognizable. For decades, it sat in a museum drawer, dismissed as a curious but unremarkable piece of nautical debris. It was, in fact, the most technologically complex object to survive from the ancient world. The true nature of this artifact, now known as the Antikythera mechanism, remained hidden until scientists began to look inside. Using high-resolution X-ray tomography, a technology that creates detailed cross-sectional images, researchers were able to peer through 2,000 years of corrosion. What they saw was breathtaking. The lump of bronze concealed an intricate clockwork of at least 30 precise bronze gears, some with fine teeth smaller than a pinhead. This was not a statue or a simple navigational tool. It was a machine. Building on these scans, teams created stunningly accurate three-dimensional models of the device, allowing them to see how the gears meshed and turned together. They realized they were looking at a hand-powered, geared calculator of astonishing sophistication. By turning a handle on the side, a user could set a specific date, and the gears would rotate to display the positions of the Sun, the Moon, and the 5 known planets. It could predict lunar and solar eclipses and even model the irregular orbit of the Moon. This was, in essence, the world's first known analog computer. Its existence shatters our previous understanding of ancient Greek technology. We knew they were brilliant philosophers and architects, but the Antikythera mechanism reveals a level of mechanical engineering and scientific knowledge we never imagined they possessed. It demonstrates that the concepts of gears and complex calculation were not inventions of the Renaissance, but were alive in the Mediterranean world centuries before the Common Era. This one device rewrites the history of technology, proving that the seeds of our own mechanical age were planted far earlier than we ever knew. High above the arid plains of Peru, a sprawling desert canvas holds giant figures only visible from the sky. The Nazca Lines, vast geoglyphs depicting spiders, hummingbirds, and mysterious humanoid forms, have fueled endless speculation. Were they landing strips for alien spacecraft or messages to ancient gods? The truth, uncovered by science, is grounded firmly in the needs of the people who called this harsh landscape home. The sheer scale of these creations made them impossible to comprehend from the ground, but modern technology finally gave researchers the vantage point they needed. Satellite imagery and high-resolution drone photography have revolutionized our understanding. These tools have mapped thousands of lines and figures with incredible precision, revealing a complex network that stretches for miles. This aerial view was not for the creators, but for us, allowing scientists to see patterns and connections that were once invisible. This mapping is also a race against time, as these fragile markings are threatened by erosion and human activity, making their digital preservation a crucial scientific mission. But how did the Nazca people without flight create such massive, perfect forms? The answer was surprisingly simple and lay scattered on the ground. Archaeologists found small pottery fragments near the lines, decorated with the same animal and geometric designs. They also discovered the remnants of wooden stakes at the endpoints of the long, straight lines. These were not alien tools, but the components of a practical, large-scale art project. The creators likely first designed a small-scale model on a portable part. Then, using ropes anchored by these stakes, teams of people could meticulously enlarge the design, clearing the dark, sun-baked stones from the desert surface to reveal the lighter soil beneath. This was a communal effort, not an otherworldly one. But why invest such immense effort in art you could never fully see? The purpose becomes clear when you understand the environment. The Nazca Desert is one of the driest places on Earth, where water was the difference between life and death. analysis of the figures shows they are overwhelmingly associated with water sources. The hummingbird, the monkey, the spider, many are directly aligned with subterranean aquifers and mountain streams that feed the narrow valleys. The lines themselves often point toward sources of precious water. This was not an astronomical calendar, but a hydrological one. Scholars now believe these geoglyphs were part of a vast ritual landscape, a desperate and beautiful plea to the gods for fertility and rain. By walking these lines in ceremonial processions, the Nazca people were not building airports for visitors from the stars. They were performing a sacred walking prayer, physically tracing the forms of animals that symbolized life and water, hoping to bring sustenance to their world. The lines were a bridge between the human and the divine, a monumental expression of hope etched into the earth itself. The vast Pacific Ocean presents a puzzle on a continental scale, a watery expanse so immense it could swallow every landmass on Earth with room to spare. Scattered across this blue desert are tiny islands, isolated specks of green separated by thousands of miles of open sea. For centuries, the presence of people on these remote islands baffled European explorers. How could ancient voyagers without maps or compasses have possibly found and settled such far-flung lands? The prevailing theory was one of accident, that helpless fishermen were simply blown off course and lucky to survive. Science, however, has proven that the truth is a far more impressive story of deliberate genius. The first major clues came not from the sea, but from human genetics. By analyzing the DNA of modern Polynesian populations and comparing it to ancient skeletal remains, researchers could trace a family tree across the ocean. This genetic roadmap revealed a clear and rapid expansion, starting from islands near Fiji and Samoa and exploding eastward. The pattern was not random. It pointed to a continuous, intentional migration, a wave of exploration that swept across 10 million square miles of ocean in just a few centuries. This was no series of fortunate accidents. It was a purposeful colonization of the Pacific. But how did they navigate? The answer lies in a complex science, a form of knowledge almost entirely lost to history and only recently rediscovered. Researchers used computer simulations to model ancient voyages, plugging in data on ocean currents, prevailing wind patterns, and seasonal weather. These digital journeys confirmed that the settlement patterns were not only possible but highly probable, using the sophisticated sailing canoes the Polynesians built. The real magic, however, was in their wayfinding. These navigators were human instruments reading the environment with a precision we can scarcely comprehend. They memorized the night sky, not just the North Star, but the entire celestial map, understanding how different stars rose and set over specific islands. They learned to read the ocean itself, feeling the subtle patterns of swells reflected from distant landmasses, a sensation like hearing a faint echo in the water. They watched for specific species of birds, knowing that a tern flying out to sea at dusk was heading toward land, while a frigate bird soaring high was a sure sign an island was near. They could even detect the faint scent of vegetation or the specific color of clouds that gathered over an unseen island. This was a complete environmental literacy, a way of seeing the world that turned the entire Pacific into a familiar highway. These navigators were not lost souls hoping for land. They were master explorers, steering their double-hulled voyaging canoes across unimaginable distances with confidence and skill, guided by a science of the sea that was passed down through generations. Their achievement stands as one of humanity's greatest feats of exploration, a testament to the power of human observation and courage. While Polynesian navigators mastered the Pacific, a very different kind of sea power was unleashing chaos in the Mediterranean. Ancient Egyptian walls tell a story of terror, carved with scenes of a mysterious naval force that shattered empires. They called them the Sea Peoples, and their sudden, violent arrival around 1200 BCE helped trigger the late Bronze Age collapse, toppling mighty kingdoms from Greece to the Levant. For over 3,000 years, these invaders remained shadowy figures, their origins and motives completely unknown. Who were these destroyers of worlds? The inscriptions gave them names like the Peliset and the Sherden, but these were just labels given by their victims. Were they a single, homogeneous army or something far more complex? The answer lay not in stone carvings, but in the bones of the warriors themselves. Archaeologists excavating a battlefield site in modern-day Israel made a crucial discovery: the skeletons of men who had fought against the Egyptian army. These were likely some of the very invaders described in the hieroglyphs. Science had a way to question these remains directly through a technique known as isotopic analysis. The method is brilliant in its simplicity. As we grow, our teeth and bones absorb minerals from our food and water, locking in a chemical signature of the geology we lived on. It is a permanent internal passport stamped with the location of our childhood. When researchers analyzed the teeth of these slain warriors, the results were stunning. The isotopes did not point to one homeland, but to many different places scattered across the Mediterranean. Some of the men had grown up in Sardinia, others in the Aegean, and still others from various coastal regions of southern Europe. This single scientific test transformed our entire understanding of the Sea Peoples. They were not a unified nation on the march. They were a coalition of disparate groups, a mixed multitude of migrants, raiders, and refugees from a world in turmoil. This new evidence paints a far more chaotic and relatable picture. The Late Bronze Age was a globally interconnected era, and its collapse was a systems failure. Climate change likely caused widespread drought and famine, while internal rebellions and the disruption of trade routes created a perfect storm. The Sea Peoples were not the sole cause of the collapse, but a symptom of it. They were a wave of desperate people set in motion by the failure of their own societies, moving across the sea in search of new land and survival, clashing with the fragile empires in their path. The Peliset, for instance, are now widely believed to be the Philistines who later settled on the coast of Canaan. They were not just destroyers, they were also settlers, their DNA now found in modern populations. Science has begun to replace the faceless horde with a human story of displacement and resilience, showing that history's great upheavals are rarely caused by a single villain, but by a cascade of failures that reshape our world. The story of human history is not a simple one of replacement, but a complex tapestry of interaction. For decades, the fate of the Neanderthals was told as a straightforward tale of superior Homo sapiens outcompeting our brutish, dim-witted cousins. But science has completely rewritten this narrative, revealing a much more intimate and poignant story. The most profound evidence did not come from a new fossil, but from the genetic code preserved within old bones. Researchers achieved the incredible feat of sequencing the entire Neanderthal genome, a monumental task that required extracting tiny, degraded fragments of DNA from fossils tens of thousands of years old. When they compared this ancient blueprint to the DNA of modern humans from around the world, they made a staggering discovery. People of European, Asian, and Native American descent all carry a small but significant amount of Neanderthal DNA, typically between 1 and 2%. This was not a result of distant shared ancestry. This was clear, direct evidence of interbreeding. Our ancestors did not simply encounter Neanderthals and drive them to extinction. They met, they coexisted, and in many cases they had families together. This genetic legacy is still active within us today, influencing everything from our immune response to our susceptibility to certain diseases. So if we did not wipe them out in a violent conquest, what actually happened? The answer lies in a perfect storm of pressures. Archaeological evidence shows that as modern humans migrated into Europe, we were not alone. Neanderthals had already been living there for hundreds of thousands of years, supremely adapted to the cold, glacial climate, but then the world began to change rapidly. Data from deep ice cores in Greenland and Antarctica provides a detailed climate record. and it shows that the period of the Neanderthals' decline was one of extreme instability. The climate swung wildly between cold and warm periods, causing the landscape to transform. The large game animals Neanderthals relied on for food became scarce or disappeared. At the same time, Homo sapiens may have possessed slight advantages. We likely had more complex social networks, allowing for trade and cooperation across larger groups. Our tools were sometimes more versatile, and our ability to innovate and adapt to new environments may have been just a little bit faster. They were not inferior, but they were vastly outnumbered. Genetic studies indicate that Neanderthal populations were always small and isolated, with little genetic diversity. When the climate shifted and competition for resources intensified, their small numbers became a critical vulnerability. They were simply more susceptible to being absorbed into the larger, growing population of Homo sapiens. The Neanderthals did not so much go extinct as they faded into our own lineage, their DNA a permanent, quiet echo of a branch of humanity that walked a different path, only to have its story merge forever with our own. While we carry traces of our ancient cousins within us, another artifact suggests a different kind of lost knowledge entirely. In the basement of the National Museum of Iraq sits a simple clay jar unearthed from a 2,000-year-old Mesopotamian site. It looks unremarkable, but its contents are anything but. Inside this vessel, researchers found a rolled copper sheet, an iron rod, and evidence that it was once sealed with an asphalt plug. To some, this is the Baghdad battery, a device that appears to defy our entire timeline of electrical discovery. Could ancient people have harnessed electric current centuries before Galvani or Volta were even born? The only way to know was to put the theory to the test. Scientists constructed precise replicas of the jar using the exact materials found in the original. They inserted the iron rod into the copper cylinder, sealed the top with asphalt to hold it in place, and then filled the jar with an electrolyte. They did not need a modern chemical solution. They used substances readily available to the Mesopotamians, like vinegar or grape juice. When they connected a voltmeter to the replica, the needle moved. This simple clay pot, with its common ingredients, was capable of generating a small but consistent electrical charge, around 1 to 2 volts. It was a functional, albeit basic, galvanic cell. This stunning result ignited a fierce debate that continues to this day. If it was a battery, what on earth was it used for? One compelling theory points to electroplating. A small electrical current is sufficient to bond a layer of gold or silver onto another metal object, a technique used for gifting inexpensive items with a precious appearance. Artisans of the time were master metalworkers, and this could have been their secret. Yet, no electroplated objects from that period have been conclusively identified. Another, more speculative idea suggests a role in religious or medical ceremony. The mild shock from such a device, perhaps administered through touch, could have been interpreted as a divine sensation or used for therapeutic numbing. Skeptics, however, offer a far more mundane explanation. They argue the jar's design is perfectly consistent with storage for sacred scrolls, made of expensive copper and iron, with the asphalt seal simply preserving the content. The single, isolated find makes it difficult to prove any theory definitively. Whether it was a revolutionary power source or an elaborate storage container, the Baghdad battery serves as a powerful reminder. It challenges our assumptions about the pace of innovation and forces us to wonder how many other breakthroughs, now lost to time, might have flickered briefly into existence, only to be forgotten for 1,000 years. The silent giants of Easter Island seem to be a permanent, immovable fixture of the landscape. How their creators moved these multi-ton moai statues for miles from the quarry to the coast was a puzzle that defied logic, inspiring wild theories of alien intervention or lost magic. The truth, revealed through practical science, is both simpler and far more brilliant. Researchers first had to dismiss the long-held idea of log rollers, as experiments showed the island's depleted forests could never have supplied enough timber. The breakthrough came from looking at the statues themselves. Many moai found along the ancient roads had a distinct forward-leaning posture and a rounded D-shaped base. This was not a stylistic choice, it was a critical engineering feature. A team of archaeologists decided to test a radical hypothesis that the statues were not dragged or rolled but walked. They built a precise concrete replica of a full-sized moai. Then, using 3 teams controlling ropes tied around the head and base, they began to rock the giant figure from side to side. With each coordinated pull, the statue pivoted on its curved base, tilting forward in a stuttering but deliberate gait. The moai did not just move, it appeared to walk majestically across the landscape, a process that would have required only a small, skilled group of people. This walking theory explained the broken moai found along the roads. Their slender necks snapped during a misstep in the complex maneuver. But this discovery only answered how they moved, not why the society eventually collapsed. The answer was locked in the island's soil. Paleoecologists, scientists who study ancient environments, drilled deep into the sediment of the island's lakes and bogs. By analyzing the layers of pollen and charcoal, they could read a history of the landscape. The core samples revealed a stunning story of ecological downfall. The pollen showed that when the first Polynesians arrived, Easter Island was not a barren grassland. It was a lush subtropical forest covered in a now extinct species of giant palm tree. The charcoal layers told the rest of the tragic tale. Over centuries, as the human population grew, the forest was systematically cleared for agriculture and for logs to transport the ever larger moai. The soil, once held in place by tree roots, began to erode into the sea. Without trees to build fishing canoes, the protein from the ocean vanished. Without forests to trap rainfall, the springs dried up. The society that had the ingenuity to walk giants across the island was ultimately brought down by the slow, creeping disaster of environmental collapse. The moai stand today not just as monuments to human achievement, but as a silent, stone warning of the consequences of consuming our own world. Another ancient object of intense faith and mystery is a simple piece of linen known as the Shroud of Turin. For centuries, this cloth has captivated believers and skeptics alike, bearing the faint, ghostly image of a crucified man. Many have claimed it is the actual burial shroud of Jesus Christ, a sacred relic miraculously imprinted with his likeness at the moment of resurrection. The debate raged for generations, a conflict between faith and tangible proof, until science was called upon to deliver a verdict. The world awaited an answer from a revolutionary technique, radiocarbon dating. In 1988, a landmark experiment was set in motion. A tiny sample of the shroud was carefully cut and divided into 3 parts. These fragments were sent, under strict secrecy, to 3 of the world's most respected independent laboratories in Oxford, Zurich, and Tucson. Their mission was singular and precise: to determine the true age of the linen fibers using the unerring clock of radioactive carbon decay. The process works by measuring the amount of carbon-14, a radioactive isotope that all living things absorb from the atmosphere. When an organism dies, it stops absorbing carbon-14, and the isotope begins to decay at a steady, predictable rate. By calculating how much remains in an ancient artifact like the shroud, scientists can pinpoint its age with remarkable accuracy. The results from all 3 labs were unanimous and conclusive. The flax plants used to weave the Shroud of Turin were harvested between the years 1260 and 1390. This placed the cloth's origin firmly in the Middle Ages, more than 1,000 years after the crucifixion. For many, this was the final word, a scientific debunking of a powerful legend. The shroud was a medieval artifact, not a first-century relic. Yet the story did not end there. The carbon dating results sparked a new wave of controversy. Critics of the findings pointed to the sample itself. They argued that the tiny piece of cloth tested might have been contaminated over the centuries, perhaps by a fire that damaged the shroud in the 1500s. Could smoke and soot have introduced newer carbon, making the linen appear younger than it truly was? Others proposed that invisible microbial contamination, a layer of bacteria and fungi coating the threads, could have skewed the results. To address these questions, scientists developed alternative theories for how the image was formed. One compelling hypothesis involves a simple chemical reaction. Researchers demonstrated that a mixture of common compounds, including myrrh and aloes used in ancient burial practices, when applied to linen and exposed to slight heat and humidity, could produce a similar faint straw-colored image. This process, known as a Maillard reaction, is the same chemical browning that occurs when you cook food. It requires no supernatural explanation, only a natural, if tragic, combination of spices, bodily fluids, and the warmth of a tomb. Despite these scientific explanations, the debate continues, a testament to the shroud's enduring power. The precise, photo-negative quality of the image remains difficult for some to fully replicate. The question is no longer just about carbon dating, but about the limits of our current understanding. Could there be a phenomenon we have not yet discovered? The Shroud of Turin stands at the crossroads of belief and evidence, a permanent enigma that science has narrowed, but perhaps not entirely solved. His golden funeral mask is an immortal symbol of ancient Egypt, but the boy behind it lived a short and painful life. King Tutankhamun's tomb, discovered nearly intact, presented a new mystery, the shocking early death of a pharaoh barely out of his teens. For decades, the leading theory was as dramatic as it was tragic, that he had been murdered by a rival, struck down by a fatal blow to the head. Early X-rays of his mummy seemed to show bone fragments within his skull, fueling speculation of a royal assassination that captivated the public imagination. The truth, however, was far more complex and would require a much deeper look. Scientists finally had their chance with a full CT scan of the mummy, a non-invasive procedure that created a complete three-dimensional map of the young king's remains. This digital autopsy searched for any evidence of violent trauma, but the results were definitive. The bone fragments spotted in the earlier, blurrier X-rays were not the result of a pre-mortem injury. They were likely dislodged during the original mummification process or even caused by the rough handling of the excavators who first unwrapped him decades earlier. There was no sign of a killing blow. The murder mystery had evaporated, leaving a more profound question in its wake. What could have killed a seemingly healthy young man with all the resources of an empire at his disposal? The answer lay not in his bones alone, but in his very DNA. Researchers performed extensive genetic testing on tissue samples from Tutankhamun and several of his close relatives. The results painted a heartbreaking portrait of a life plagued by illness. The boy king suffered from multiple genetic disorders inherited from his parents, who were almost certainly brother and sister. This royal inbreeding, common among Egyptian pharaohs to preserve their divine bloodline, had devastating consequences. The genetic analysis revealed that Tutankhamun had a crippling bone disease known as Kola disease, which would have caused the bones in his foot to collapse. He also had a severe club foot, making it incredibly difficult and painful for him to walk. Canes were found in his tomb not as ceremonial items, but as essential tools for daily life. This frail young man could not have stood in a chariot for battle, as artists often depicted him. He was likely in constant pain. To make matters worse, the tests also found genetic material from the malaria parasite, indicating he had contracted a severe case of the disease, possibly multiple times. His immune system would have been relentlessly compromised, but the final clue, the one that likely ended his life, was found on his leg. The CT scan revealed a severe, unhealed fracture just above his left knee. This was not a clean break, but a compound fracture that would have torn through the skin. In his weakened state, battling malaria and chronic pain, such a wound would have been catastrophic. An infection would have spread rapidly through his body, leading to sepsis or gangrene. The most plausible scenario is not a shadowy conspiracy, but a tragic accident. A fall that would have been minor for a healthy person, perhaps a stumble while walking with his canes, proved fatal for the fragile pharaoh. King Tutankhamun's death was not a sudden act of political violence, but the slow, cumulative failure of a body burdened by generations of royal tradition and genetic misfortune. While King Tut's fragile body succumbed to its many ailments, a structure built by the Romans over 1,500 years earlier still stands defiantly intact. The Pantheon in Rome boasts the world's largest unreinforced concrete dome, a masterpiece that has weathered earthquakes, invasions, and the relentless passage of time. Its endurance is a silent rebuke to our own modern infrastructure, where concrete bridges and buildings often show alarming decay after just a few decades. What secret recipe did the ancient Romans possess that we have somehow forgotten? The answer was locked inside the concrete itself, waiting for science to develop the tools to see its microscopic structure. Modern researchers turn to a phenomenal machine called a synchrotron, which produces X-rays of incredible power and precision. Using a technique known as synchrotron X-ray diffraction, they could essentially take a molecular-level photograph of the Roman concrete, identifying every single crystal within the ancient mix. What they found was a mineral so rare it is almost never seen in modern concrete, a crystal called aluminous tobermorite. This was the magic ingredient, and its creation was the result of a brilliantly counterintuitive process. The Romans did not use pure, clean water in their mix. Instead, they deliberately combined volcanic ash, known as pozzolana, with lime and seawater. This might seem like a recipe for disaster, as seawater would corrode modern steel-reinforced concrete from the inside out. But for the Romans, it initiated a slow, long-term chemical reaction. When the salty seawater mixed with the volcanic ash and lime, it began a process that never truly stopped. Over centuries, the water slowly seeped through the concrete, dissolving components of the volcanic ash and allowing them to recrystallize, forming these strong, interlocking plates of tobermorite. This crystal actually fills in any tiny cracks that begin to form, making the concrete self-healing. The material does not weaken with age, it grows stronger. This is the complete opposite of modern concrete, which is designed to set quickly and remain chemically stable, but is ultimately brittle and vulnerable to cracking. The Roman method was a form of slow cooking, a patient chemistry that traded immediate convenience for near-perpetual durability. Our modern world, built for speed, had simply lost the formula for building forever. This discovery is more than a historical footnote, it is a blueprint for our future. Scientists are now actively working to reverse engineer Roman concrete, hoping to create a new generation of self-healing, environmentally resilient materials. The ultimate irony is that to build a more durable future, we are being forced to look back and finally learn the lessons written in stone by the ancient world. The same chemistry that built the Pantheon's eternal dome also preserved a much darker record of the ancient world. Across the peat bogs of northern Europe, the acidic, cold, and oxygen-poor water created a perfect environment for a different kind of time capsule. For centuries, peat cutters have unearthed the haunting remains of men, women, and children, their skin tanned to leather, their features eerily recognizable after 2,000 years in the swamp. These bog bodies were not simply lost souls. They were messages deliberately placed in the water, and modern forensic science has finally begun to translate them. Early theories suggested these were victims of accidental drowning or common criminals, but the evidence told a different, more ritualistic story. CT scans of the bodies revealed causes of death that were anything but accidental. One man, known as Toland Man, was found with a perfectly preserved noose still wrapped around his neck. Another, Grobel Man, had his throat slit from ear to ear with such force that it nearly decapitated him. The violence was precise and overwhelming, pointing not to casual murder but to formalized killing. Isotopic analysis of their bones and teeth added another layer to the mystery. This technique measures the chemical signatures locked into our bodies from the food and water we consume, revealing where a person lived. For many bog bodies, these isotopes showed they were not locals to the bog area where they were found. They had traveled from distant regions, suggesting they may have been special captives, perhaps nobles or even willing victims chosen for a sacred purpose. The most intimate clues, however, came from within their own bodies. Scientists analyzed the contents of their stomachs and intestines, recovering a detailed menu of their final meals. Toland man's Last Supper was a simple porridge of barley, flax, and seeds, consumed 12 to 24 hours before his death. Grobel man had eaten a similar meal, but with over 60 different types of wild seeds and weeds, suggesting a gruel made from the last scraping of the grain stores. This was not a festive feast. It was a spare, almost ritualistic meal, possibly consumed as part of a ceremonial preparation. The time of year was also preserved in that final meal. The presence of certain seeds and grains indicates that many of these sacrifices took place in the late winter or early spring, a time of year associated with fertility gods and the desperate hope for a successful planting season. The bodies themselves were often weighed down with branches or stones, and some, like the young woman known as Id Girl, had one side of her head shaved. These were not acts of disrespect, but part of a solemn ritual, an offering to the gods of the marsh in exchange for fertility and order in the world above. The bog bodies do not represent random violence, but a deeply ingrained belief system. They were chosen individuals, fed a final, symbolic meal, and then offered to the gods in a brutal yet sacred transaction. Science has transformed these silent figures from anonymous corpses into poignant individuals, allowing us to witness the final hours of their lives and understand the profound and sometimes terrifying beliefs that shaped the Iron Age world. The legend of a city swallowed by the desert is a story as old as time itself. For centuries, travelers in the Arabian Peninsula whispered of Ubar, a magnificent city of towering pillars and immense wealth that was punished for its arrogance, vanishing into the sands as if it had never existed. Dubbed the Atlantis of the Sands, it was considered nothing more than a fable, a moral tale spun from the threads of imagination. The search for this lost metropolis, however, would not be one with shovels and camels, but with a view from the edge of space. Scientists turned to an unexpected tool, the space shuttle. During one of its missions, the shuttle employed a powerful imaging radar system designed to penetrate the Earth's surface. While ordinary photographs see only sand dunes, radar waves can slip through the dry, loose grains and bounce off solid structures hidden below. When the data was processed, the results were staggering. The radar maps revealed a spiderweb of faint, ancient lines crisscrossing the desolate expanse of southern Oman. These were not natural features. They were the fossilized tracks of countless camel caravans, paths worn deep into the earth over centuries and then buried by the shifting dunes. It was a ghostly highway system, and all of its threads led to one central point. Armed with this celestial map, archaeologists descended upon the site. Following the radar's guidance, they began to excavate where all the tracks converged. Beneath the sand, they uncovered the unmistakable outline of a massive octagonal fortress, with towers soaring 30 feet high and walls 10 feet thick. This was no small trading post. They found the remains of large buildings, irrigation systems, and artifacts that spoke of immense wealth and global connections. Most tellingly, they uncovered enormous deposits of frankincense resin, the precious incense that was worth its weight in gold in the ancient world. This was the confirmation. They had found Ubar. The city was not a myth, but a critical linchpin in a global economy. It was a fortified hub where camel caravans, laden with frankincense harvested from the rare trees of southern Arabia, would gather before beginning the perilous journey north to supply the temples and palaces of Rome, Persia, and Egypt. The city's dramatic end was also written in the stone. The excavations showed that Yuba was not punished by divine wrath, but by its own success. The great fortress was built directly over a large limestone cave, which served as the city's primary water source. The constant weight of the heavy walls and the traffic of caravans eventually caused the cavern's roof to collapse, swallowing a large portion of the city into a sinkhole. The desert sands did the rest, silently reclaiming what was left of the once great capital of incense. Science had turned a campfire legend into a historical fact, revealing a city that mastered the desert only to be ultimately defeated by the very ground beneath its feet. The silent stones of Stonehenge tell only part of the story. To truly understand this ancient wonder, we must uncover the lives of the people who raised them. What did they eat and where did they come from? Science has turned from the monument to the middens, the ancient garbage heaps, to find the answers. At the nearby settlement of Durrington Walls, archaeologists sifted through millennia of discarded debris, and their findings revealed a society in celebration. The sheer volume of animal bones was staggering, primarily from pigs and cattle. But these were not just the remains of daily meals. The bones themselves bore the marks of a systematic feast. Cut marks showed the animals were butchered into standard portions, likely to feed huge crowds. Many of the pig bones came from animals slaughtered at just 9 months old, a sign they were being raised for a specific, large-scale event rather than for long-term survival. This was evidence of epic, recurring feasts capable of feeding thousands of people at once. Yet, the most fascinating clues came from the chemistry of the pottery found alongside the bones. Researchers performed lipid residue analysis on the ancient cooking pots. They discovered that the fats trapped in the clay were overwhelmingly from pork and dairy products. These were not just meals, they were rich, high-protein feasts, the kind of food needed to fuel the immense labor of moving giant stones and to reward the communities who traveled great distances to help. But who were these feasters? The answer is written in their teeth. Isotopic analysis of the enamel from human remains found in the area acts as a geological tape recorder of a person's childhood. The minerals in the food and water we consume as children leave a unique signature based on the local bedrock. When scientists tested the teeth of individuals buried near Stonehenge, they found a wide variety of these chemical fingerprints. Some individuals had isotopic signatures matching the local chalklands of Wessex, but many others told a different story. Their teeth contained isotopes that could only have come from much further away, from the ancient rocks of Wales and even from the Highlands of Scotland. This means the people who built and used Stonehenge did not all come from one local tribe. They were a gathering of communities from all across Britain, a pilgrimage of different cultures united by a shared purpose. They traveled for weeks, bringing their own livestock with them, converging on this sacred plain to work together, to feast together, and to bury their dead. The monument was not built by slaves or a solitary kingdom, but by a collective effort of an entire island, their cooperation forged over shared meals beneath the vast English sky. The shadow of the Black Death stretched across continents, a phantom killer that wiped out half of Europe's population in the 14th century. For centuries, the source of this apocalyptic plague was a terrifying unknown, its origins shrouded in tales of miasmas and divine punishment. The answer, however, was not in historical texts alone, but in the microscopic remnants of the pathogen itself, preserved in the teeth of its victims. Scientists turned to a revolutionary technique, extracting ancient bacterial DNA from the dental pulp of skeletons buried in mass graves across Europe. This genetic material, a fragile echo of the disease, was painstakingly sequenced and compared. The results were clear. The killer was the bacterium Yersinia pestis, the same agent behind modern bubonic plague. But this only identified the weapon, not its point of origin. To trace the outbreak to its source, researchers needed to find the oldest strain, the ancestral version from which the European plague evolved. The search led them to a seemingly unlikely place, a 14th century cemetery in what is now Kyrgyzstan in Central Asia. Here, tombstones from the 1330s were inscribed with references to a mysterious pestilence, a crucial clue. When scientists analyzed skeletons from these graves, they struck genetic gold. The strain of Yersinia pestis they found was the direct ancestor of all the strains that would later ravage Europe. This was the ground zero of the pandemic. The evidence painted a new and definitive picture. The plague did not spontaneously generate in Europe. It erupted in Central Asia in the 1330s, traveling along the bustling trade routes of the Silk Road. Infected fleas living on black rats hitched rides in bundles of cloth and sacks of grain carried in merchant caravans. From this central hub, the disease moved inexorably westward, reaching the bustling ports of the Black Sea and then boarding Genos trading ships that carried it to the heart of the Mediterranean. The greatest catastrophe in human history began not with a bang, but with a tiny, lethal bacterium awakening in a remote corner of Asia, its journey across the world enabled by the very networks that connected humanity. These strange bronze objects seemed to defy any simple explanation. Found scattered across the former Roman Empire from Britain to Hungary, each hollow dodecahedron is a geometric marvel, a 12-sided object with a pentagonal face, a hole in every side, and a small knob at each corner. No two are exactly alike in size or detail, and not a single written record or artistic depiction from the Roman world mentions their purpose. For generations, they were one of archaeology's most charming and persistent puzzles. Were they religious relics, children's toys, or perhaps intricate candle holders? Modern science has systematically dismantled these romantic theories. Material analysis shows the bronze used was often quite expensive, ruling out simple playthings. The intricate, non-standardized designs and lack of soot residue make the candle holder idea highly improbable. 3D scanning and digital modeling allowed researchers to test another popular idea, that they were navigational tools for calculating distances. The models proved that the varying hole sizes and knob placements were too inconsistent for any reliable mathematical or surveying function. One by one, the most common guesses were eliminated, forcing a turn toward more practical, grounded possibilities. The most compelling hypothesis that has emerged casts these objects not as mystical symbols, but as highly specialized tools for Roman industry. One theory suggests they were sophisticated gauges for manufacturing. A craftsman could have used the different-sized holes to quickly measure the diameter of metal rods, perhaps for creating standardized lead pipes for the empire's famous plumbing systems. A plumber could slide a soft lead strip through a hole until it fit snugly, ensuring a perfect, consistent diameter for every pipe segment. Another, equally plausible theory involves a different kind of craft, textile work. The knobs could have served as a fixed frame for creating intricately sized and patterned crochet gloves. By wrapping yarn around the knobs in a specific sequence, a craftsperson could produce a perfectly fitted, 5-fingered glove with a high degree of repeatable accuracy. In an empire that stretched across varied climates, standardized warm gloves would have been a valuable commodity for soldiers and civilians alike. Rather than a single, universal answer, the dodecahedron may have been a versatile template, its exact use customized by the artisan who owned it. This shift in understanding is profound. It transforms the dodecahedron from an object of magic into a testament to Roman practicality, a tangible piece of the everyday ingenuity that built an empire, one perfect pipe or warm glove at a time. High on the sun-baked cliffs of the American Southwest, the intricate stone cities of the ancestral Pueblones, once known as the Anasazi, stand as silent monuments to a thriving civilization. Their sudden disappearance from places like Mesa Verde around the end of the 13th century has long been a haunting puzzle. Did they fall to invaders, or did some other, slower disaster force them to abandon their magnificent homes? The truth was not written in their artifacts, but in the gnarled wood of ancient trees. dendrochronologists, scientists who study tree rings, assembled a year-by-year climate record stretching back over 1,000 years. Each ring tells a story of rainfall, and the story they told for the 1200s was one of unrelenting catastrophe. The data revealed a mega-drought that gripped the region for nearly 50 years, a period of aridity so severe it dwarfed any dry spell in modern memory. Springs would have vanished, and carefully tended fields of corn and beans would have withered to dust under a brutal sun. Yet a drought alone does not explain the evidence of chaos left behind. As the climate crisis deepened, the archaeological record turns dark. In once peaceful villages, researchers found evidence of fortified walls and gates. Some settlements show signs of violent conflict, including unburied bodies and evidence of cannibalism. It seems that as the life-giving water disappeared, the social fabric began to tear. The struggle for survival turned communities against one another, fighting over the last remaining pockets of fertile land and reliable water sources. This was not a single sudden event, but a slow, grinding collapse. The very sophistication that allowed them to build their cliffside palaces may have contributed to their downfall. Their large, concentrated populations had depleted local resources like timber and game long before the drought began, leaving them with no buffer when the rains failed. Faced with starvation and internal strife, the people made a difficult, deliberate choice. They did not vanish from the earth. They dispersed. They broke into smaller family groups and migrated across the southwest, joining or forming new communities along rivers like the Rio Grande. Their cultural knowledge and traditions traveled with them, living on in the Hopi, Zuni, and other Pueblo peoples of today. The empty cliff dwellings are not a tomb, but a testament to human resilience, the story of a people who, when their world crumbled, chose to walk away and begin again. A different kind of map promised to rewrite the history of the New World. The Vinland map, a stunning parchment unveiled to the public in 1965, depicted a mysterious landmass west of Greenland labeled as Vinland. If authentic, it was definitive proof that Viking knowledge of North America had been recorded centuries before Christopher Columbus set sail. The map ignited a firestorm of debate, pitting hopeful historians against skeptical scholars for decades. The resolution would not come from studying the parchment itself, but from a microscopic analysis of the ink that traced its lines. Researchers turned to a non-destructive technique called Raman spectroscopy, which uses a laser to identify the molecular fingerprint of a material. They focused the laser on the map's distinctive yellow-brown lines, searching for the chemical signature of medieval iron gall ink, the standard for the period. Instead, the spectrometer detected the clear, sharp signal of anatase, a specific crystalline form of titanium dioxide. This was the smoking gun. Anatase is a synthetic compound, an industrial product that did not exist in its pure, pigment-grade form until the 1920s. Its presence was an anachronism, a modern chemical trapped in a supposedly medieval document. The ink itself was a clever forgery, likely created to mimic the appearance of aged iron gall ink, but betraying itself with 20th century chemistry. This single, precise scientific test settled the long and bitter debate. The Vinland map was not a medieval treasure, but an elaborate and ingenious hoax. Its story serves as a powerful cautionary tale, reminding us that even the most compelling historical evidence must surrender to the unbiased verdict of forensic science. The same pollen that revealed the fate of the ancestral Pueblones has now been pulled from the bottom of ancient eastern Mediterranean lakes, telling a far older and more catastrophic story. Around 1200 BCE, the vibrant, interconnected world of the Late Bronze Age imploded. The mighty Hittite Empire in Anatolia vanished. The grand palaces of Mycenaean Greece burned to the ground. In a single human lifetime, trade routes stretching from Mesopotamia to Egypt disintegrated, literacy disappeared, and entire civilizations simply ceased to be. What colossal force could have shattered this sophisticated world? For decades, theories pointed to invasions like the Sea Peoples or to earthquakes. But science has uncovered a far more insidious enemy, one that starved empires from the inside out. The key evidence was hidden in mud. Scientists extracted deep sediment cores from the bottom of lakes and marshes across the region. By analyzing the layers of fossilized pollen trapped in this mud, they could reconstruct a year-by-year history of the local vegetation and, by extension, the climate. The story the pollen told was one of unmitigated disaster. The data revealed the onset of a 300-year megadrought, a dry period so severe and prolonged it would have crippled the agricultural foundation of every kingdom. Imagine year after year of failing harvests, of grain stores slowly emptying, of populations growing increasingly desperate. This was not a single bad season. It was a climatic shift that made survival itself a daily struggle. But the drought was only the first act of this tragedy. Scientists also turned to another natural archive, the ice sheets of Greenland. By drilling deep ice cores, they could analyze tiny bubbles of ancient atmosphere and layers of volcanic ash trapped in the ice. The cores from this exact period show a major spike in volcanic sulfates, evidence of a colossal eruption or perhaps a series of them somewhere on the planet. Such an event would have thrown vast quantities of ash and sulfur dioxide into the stratosphere, blocking sunlight and creating a volcanic winter that could have lasted for years. The combination was devastating. A relentless, generations-long drought was now compounded by a sudden, sharp global cooling. Crops would have failed from both a lack of rain and a lack of sun. Famine would have spread like wildfire. This was the perfect storm. The great empires, already straining under the weight of the drought, now faced internal rebellions from starving citizens. The complex international trade networks that supplied tin for bronze and luxury goods collapsed as every kingdom turned inward to fight for its own survival. It was in this atmosphere of total systemic failure that the migrations began. The so-called Sea Peoples were likely not a cause of the collapse, but a symptom. A wave of climate refugees and displaced groups set adrift in a world that was coming apart at the seams. They were both victims and vectors of the chaos, moving across the Mediterranean and clashing with the fragile remnants of the old order. The Bronze Age did not fall to a sword, but to a slow, relentless squeeze of drought, followed by the knockout punch of a volcanic winter. A 1-2 blow from the climate that even the mightiest empires could not withstand. Its legendary strength was forged from a most unexpected ingredient. The Great Wall of China snakes across mountains and deserts, a dragon of stone and earth so immense it was once said to be visible from the moon. For centuries, its construction seemed an almost superhuman feat. How could ancient laborers possibly build and maintain a barrier of such impossible scale? The first step in solving this mystery was to understand its true dimensions, a task that proved too vast for any ground-based survey. The answer came from orbit. Scientists using satellite imagery and LIDAR, a laser-based scanning technology, finally mapped the entire system. The results were staggering. The wall is not a single continuous structure, but a sprawling network of rammed earth, stone, and brick barriers, along with trenches and natural defensive features like rivers and hills. When all its branches are counted, the total length exceeds 21,000 kilometers, or over 13,000 miles. This was not just a wall, it was the largest construction project in human history, a continent-spanning monument to defense. But mapping its length was only half the puzzle. The more perplexing question was its endurance. How have sections built during the Ming Dynasty, over 600 years ago, remained standing while modern concrete crumbles after a few decades? The secret was hidden in the mortar between the bricks. Archaeologists taking samples for analysis expected to find a standard lime-based paste. Instead, their chemical tests revealed a strange and wonderful additive, sticky rice flour. This common cooking ingredient, when mixed with slaked lime, created a reaction that formed a dense, durable matrix of calcium carbonate crystals. This organic-inorganic composite was far stronger and more water-resistant than pure lime mortar. In essence, the builders had created a kind of prehistoric super glue. Think of the difference between a simple sandcastle and one fortified with a binding agent. The sticky rice mortar acted as that binder, filling in microscopic gaps and creating a flexible yet incredibly resilient bond that could absorb the stresses of earthquakes and freeze-thaw cycles without cracking. This was a revolutionary material science innovation, a perfect marriage of culinary tradition and engineering genius. The laborers who raised the Great Wall were not just brute strength, they were master chemists, their recipe so effective that it has withstood centuries of weathering. The wall stands today not only as a symbol of imperial power, but as a testament to the timeless ingenuity that can turn a simple bowl of rice into the key that locks a nation together. Their longships were not just vessels but dragons of the sea, capable of feats that defied the brutal North Atlantic. For centuries, the Viking journeys to Iceland, Greenland, and even North America seemed almost supernatural. How could these open boats, seemingly so fragile, conquer an ocean known for its savage storms and impenetrable fogs? The answers have been pieced together through the broken hulls of shipwrecks and the daring voyages of modern adventurers. Archaeologists examining the Oseberg and Gokstad ships in Scandinavia uncovered a revolutionary design. The secret was a unique combination of strength and flexibility. Unlike the rigid, heavy frames of later vessels, the Viking longship was built with overlapping planks, known as clinker construction, which were riveted together. This created a hull that could twist and bend with the waves, riding over them like a sea serpent rather than fighting against them. A deep keel provided stability against the wind, while a shallow draft allowed them to beach on any shore, making them the ultimate raiding and exploration machines. But could these ships, preserved in museums, truly handle the open ocean? Experimental archaeology provided the ultimate test. Teams built exact replicas like the ship Saga Sigla and sailed them across the Atlantic. These modern Vikings faced the same conditions as their ancestors, proving that the ships were not only seaworthy but remarkably fast and dry, their sleek design cutting through towering waves that would have swamped a less agile vessel. Yet a sturdy ship is useless without a way to guide it. Under the perpetual gray cloud cover of the North Atlantic, how did they know which way to sail? The saga spoke of a magical tool, a sunstone that could reveal the sun's position even on a completely overcast day. For a long time, this was dismissed as pure myth. Then, scientists turned their attention to a crystal found in Iceland, a form of calcite known as Icelandic spar. This transparent stone has a unique property called birefringence. When you look through it, you see a double image, but when you hold it up to the sky and rotate it correctly, the double images merge into one single clear point directly aligning with the hidden sun. It acts as a perfect polarizing filter, reading the patterns of polarized light in the atmosphere that are invisible to our naked eyes. Researchers proved that with a simple sunstone, a skilled navigator could pinpoint the sun's location with an accuracy of within a single degree, even at twilight or through thick fog. This was not magic, it was sophisticated optical physics. The Viking navigator was a master of his environment, reading the wind, waves, and wildlife, and now armed with a crystal that could literally see through clouds. Together, the revolutionary longship and the ingenious sunstone transformed the North Atlantic from an impassable barrier into a Viking highway, paving the way for the first European footsteps on the American continent. Within the silent halls of a Cretan museum rests a small, fired clay disc that holds one of archaeology's most stubborn secrets. The Phaistos disc, discovered in 1908, is covered on both sides with a spiral of stamped symbols, a total of 241 tokens, featuring everything from human heads and shields to bees and lilies. Not a single other artifact like it has ever been found, and its message has resisted translation for over a century, a locked door with no key. How do you even begin to solve a puzzle when you do not know the rules of the game? Science has stepped in with a new set of tools, turning from shovels to algorithms. Researchers have employed the power of computational linguistics, feeding the sequence of symbols into computers to perform a statistical analysis. The goal is not to find a magic dictionary, but to understand the disk's fundamental structure. By analyzing how often certain symbols appear and which symbols tend to follow others, the software can detect patterns that are invisible to the human eye. These patterns strongly suggest the writing is not a simple alphabet, but a syllabic script where each symbol represents a syllable, like a piece of a spoken word. This is a monumental deduction, as it tells us what kind of lock we are dealing with. But what is the message inside? The most tantalizing recent hypothesis comes from a deep study of the symbols themselves, particularly those that repeat in a specific sequence. Some scholars note the frequent appearance of a symbol that looks like a plumed head, alongside another that resembles a rounded architectural structure. They propose that this combination, repeated in a rhythmic, almost chant-like pattern throughout the spiral, could be a reference to a mother goddess, a central figure in Minoan religion. The entire disk, then, might not be a royal decree or a tax record. It could be a prayer, a rhythmic hymn or incantation, physically stamped into clay to be read aloud in a sacred ritual. While this theory is far from proven and many linguists remain skeptical, it demonstrates a powerful shift. Science may not yet have provided the final translation, but it has dramatically narrowed the field of possibility. It has filtered out the noise of endless speculation, guiding us away from wild guesses and toward the most statistically probable meanings. The disk is no longer a complete mystery, but a structured text waiting for its final cipher, its silent symbols slowly being coaxed into speech by the patient, logical voice of modern analysis. The great beasts of the Ice Age inspire a special kind of awe. Woolly mammoths shaking the ground, saber-toothed cats with teeth like daggers, and giant ground sloths taller than houses once roamed every continent except Antarctica. Then, in a geological blink of an eye, they were gone. The disappearance of these megafauna is a planetary murder mystery on a grand scale, and for decades the suspects have been clear: climate change and humankind. The evidence against humanity is compelling. The Blitzkrieg hypothesis paints a dramatic picture. As early humans spread across the globe, they encountered animals that had never learned to fear them. These skilled hunters, armed with sophisticated stone-tipped spears, could have hunted the slow-breeding giants to extinction with startling speed. The timeline seems to fit. In North America, the arrival of the Clovis people coincides almost perfectly with the rapid decline of mammoths and mastodons. But is this the whole story? The case against climate change is equally powerful. The end of the last ice age was not a gentle warming, it was a roller coaster of wild temperature swings. Ice cores from Greenland and Antarctica reveal a climate lurching violently between cold and warm periods, causing entire ecosystems to transform in just a few generations. The vast, grassy steppes that fed the mammoths shrank, replaced by forests that offered little sustenance. For a creature adapted to bitter cold, this rapid environmental chaos would have been catastrophic. So which was it, the spears of humanity or the shifting climate? Science has moved beyond this simple either-or debate, and the answer emerging from ancient fossils and ice cores is a complex and devastating synergy. Radiocarbon dating of thousands of megafauna bones has created a precise timeline of their disappearance across the globe. This data shows that the extinctions did not happen everywhere at once, but in waves that closely tracked the movement of humans into new land. Yet, in many of these places, the human arrival also coincided with one of those sharp, unpredictable climate shifts. This was a fatal one-two punch. A population of mammoths already stressed by a rapidly changing habitat, their food sources dwindling and their migratory routes disrupted, would have been far more vulnerable to even a modest amount of hunting. The loss of just a few key individuals, the matriarchs who held the herd's knowledge of water sources, could have tipped the entire population into an irreversible decline. The great beasts were not simply wiped out by one force or the other. They were caught in a vice, squeezed between the changing world beneath their feet and a new, intelligent predator on the horizon. Their extinction serves as a profound and ancient lesson in how multiple pressures, each manageable on its own, can combine to create an unstoppable tide of collapse. From the silent giants of Easter Island to the star charts of the Antikythera mechanism, our journey through 25 solved mysteries reveals a profound truth. Science has become our greatest time machine, transforming whispered legends into chapters of human history. Where once we had only speculation, we now have evidence written in DNA, in tree rings, and in the very chemistry of ancient stone. We have watched as genetic sequencing rewrote the story of our own cousins, the Neanderthals, revealing their legacy within us. We have seen satellite radar pierce desert sands to uncover a city of legend, and watched as simple chemistry decoded the secret of Roman concrete. Each breakthrough is a testament to a simple, powerful idea that our past is not lost but waiting to be read with the right tools. The greatest mystery of all may be the limitless potential of human curiosity itself, armed with the scientific method. Yet for every puzzle solved, a new enigma emerges. The meaning of the Phaistos disk remains just beyond our grasp, and the true purpose of the Roman dodecahedron still sparks debate. Countless other secrets lie buried, waiting for the next generation of explorers and innovators to ask the right questions. The conversation about our past is far from over. We want to know which of these scientific revelations reshaped your understanding of history the most. Was it the walking moe, the Viking sunstone, or the tragic DNA of King Tut? Share the mystery that amazed you in the comments and keep the spirit of discovery alive. The silent whispers of our past are about to become a chorus. While we have witnessed science unravel so many enigmas, we are standing at the threshold of a new era of discovery, powered by technologies that were once the stuff of science fiction. The next frontier lies not in grand excavations, but in microscopic analysis. Imagine reading history not from scrolls, but from proteins. A revolutionary field called paleoproteomics is now allowing scientists to recover and sequence ancient proteins from bones and artifacts millions of years old. Unlike DNA, which degrades quickly in many climates, proteins are far more durable. This could finally allow us to identify the biological sex of incredibly ancient hominid fossils, trace the domestication of animals through the milk residues left on ancient pottery, or even identify specific diseases that afflicted our earliest ancestors. At the same time, methods for extracting ancient DNA are becoming astoundingly sensitive. We are moving beyond sequencing whole genomes from well-preserved permafrost mummies. Scientists are now developing techniques to pull minuscule fragments of DNA from cave dirt, from the calcium carbonate crusts on teeth, and from the very sediments where our ancestors walked. This could reveal which human species occupied a cave, even if they left no bones behind, painting a far richer picture of our deep prehistory. Perhaps the most tantalizing frontier is the decipherment of lost languages. For puzzles like the Voynich manuscript, that bizarre, illustrated codex written in an unknown script, artificial intelligence offers a new kind of key. AI systems can analyze these texts at a scale and speed impossible for humans, searching for hidden syntactic patterns, phonetic rules, and statistical correlations across thousands of pages. They can compare the unknown script to every documented language system on Earth in minutes, searching for a linguistic cousin. This same computational power is being trained on other great undeciphered scripts, like the Indus Valley script from ancient India, and even on the final, stubborn sections of the Phaistos disk. So which legendary mysteries might be the next to fall? The tomb of Alexander the Great, lost for centuries despite his world-shaking fame, has eluded every generation. But new remote sensing technologies, combined with these advanced biomolecular techniques applied to unmarked graves, could one day identify his remains. The purpose of the massive, enigmatic stone spheres of Costa Rica, perfectly round and scattered through the jungle, could be revealed through soil chemistry and residue analysis, telling us if they were astronomical tools, status symbols, or territorial markers. The fate of the Ark of the Covenant, whether destroyed, hidden, or mythologized, might one day be traced through the study of ancient texts and the archaeology of potential resting places like Ethiopia or Jerusalem. The coming decades will not just answer old questions, they will ask new ones we have not yet even thought to pose. The conversation with our past is accelerating, and we are only just beginning to hear the reply.